Alright, welcome. We're going to do part 2. Alright, so we're into factoring. So here we go. It says, always check for a GCF. So we're always going to be looking for a greatest common factor before. We have a couple different methods. So what method do you use? This we call difference of perfect squares. 3 terms, we just call this like the diamond method. 4 terms, factor by grouping. So for this one right here, you could do difference of perfect squares where we square root each one. You could also do the diamond method where you get negative 64 and 0. So what two numbers multiply negative 64, but our b value is 0. So you would get negative 8 and 8. Again, we could put that into the box, but this is, we don't have an a value here, so we're just going to be able to go straight to that. Here we can shortcut, so the answer is yes, because a is equal to 1. And so that's where we just go ahead and factor what times 8 adds to 6, and that would be 4 and 2. So we get x plus 4 and x plus 2. Here we can't shortcut why a is not equal to 1. And so what we have to do is we have to do 3 times negative 4, which is negative 12. I would get to a value of 1. That's going to be positive 4 and negative 3. This is where we draw our box. And we're going to put the first value, 3x squared here. Second value, negative 4. And then we fill in these two with 4x and negative 3x, those two numbers that we just got from here. And then we just simply pull a GCF out of each. So this is going to be 3x. This is going to be 4. This is going to be just x. And this is going to be negative 1. And you got to multiply back to see if this was true. X times 3x, yes, 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 and yes. So we end up with x minus 1 and 3x plus 4. And then 4 terms, you can just throw it in the box. Just remember, last number goes in the bottom right, first number goes in the top left, and then these two you can swap. Don't matter. And then you just GCF out. So this looks like a 3x. This looks like just x. This looks like positive 2. And this looks like a positive 4. And then just double check. 4x, 8, 3x squared, 6x. So that looks good. So we get 3x plus 4 and x plus 2. What is the standard form of quadratic? Well, that would be ax squared plus bx plus c equals 0 or equals y or equals f of x. Depends upon how you want to write it, but this is the main part. That is our standard form. All right, so on to factoring. So here, I see a GCF first of all, so 12, 33, and 6. It looks like I can pull a 3 out of that, and a y. So that's going to be 4y squared plus 11y minus 2. And then I can see if this is factorable. It's a negative 8 and 11. Now, the only factors of 8 are 4, 2, and 8 and 1. None of those would make 11. So this is not factorable anymore. We can't do any more here. So we're just going to leave it as this. And we have factored it. We GCF'd. So that is factored. Next, we're going to just basic x factoring. 10, negative 7. What multiplies to 10 adds negative 7? I believe negative 5, negative 2. So we're going to get x minus 5, x minus 2. We get to use the shortcut. This one also shortcut, 48 and negative 14. So what multiplies to 48 adds to negative 14, I believe. Would that be 8 and 6, right? I think. I always have to double check that one. 8 and 6 would be, no, sorry, negative 8 and negative 6 would be the one for that. And again, shortcuts, we get to do x minus 8 and x minus 6. All right, factoring again. We got negative 18 and 7. So we want to multiply this. And again, a lot of these was, this was positive, the bottom was negative, so we got 2 negatives. This time this is negative and this is positive. So one's going to be negative, one's going to be positive. I'm thinking 9 and 2 is going to make 7, but we'll be doing it by subtraction. So the 2 is going to be negative, 9 is going to be positive. That would make a negative 18, but a positive 7, so we get x plus 9 and x minus 2. All right, so here's the first one that we can't use our shortcuts. We have to use our little bit longer form way of doing it. We still start with this, but we do 3 times -2, which is -6, and 1 at the bottom. And in fact, we kind of got the answer right here. It is 3 and -2, which happens to do that. And so when we draw our box, we're going to get 3x squared here, -2, and then these two pieces I just got from my little diamond or x, whatever you want to call it, right there. And so here we pull out, I believe, an x here. Here it looks like I'm going to pull out a 1. Here I get to pull out a 3x, and here I get to pull out a -2. Double check to see if everything multiplies back together. It does, and we're done. 3x minus 2, x plus 1. Then we do it again. 2 times 6 is 12, multiplying to 7. 2 and 6 are pretty close, but that's not going to work. But I believe 4 and 3 will work. And so we got 2x squared here, 6 here, and then my two little pieces I just found, 4x and 3x. And we can factor out an x that way. I factor out a 2. I can factor out a 2x, and I can factor out a 3, and we just double check. Does everything multiply? It does, so we get x plus 2 and 2x plus 3. All right, a lot of factoring. All right, so I'm going to show you this. So we could factor this by, it's a difference of squares, so if we could square root each of these, we get x and 7. So we could do x plus 7, x minus 7. That's our answer right there. You could also just say what multiplies to -49 adds to 0. And again, that would be positive and -7. So you could do both of those. This is factored by groupings. So again, we just put it in our box. First number, top left. Last number, bottom right, and then these two don't really matter where we put them. And we factor out right here. I'm going to be able to take out an x here. Take out a 4x squared. And then here, this way, it looks like I can pull out a 4 as well. And then this way, I can pull out a 3. Now, notice that we have negatives in here. So we have to be careful to make sure we get this right. So 4x squared times x is that, but 4x squared times 4 is not -16. So I'm thinking about making this negative. If I do that, this isn't. So that also has to be negative, and then -4 and -3 does make positive 12. So that would work. So you kind of just got to make sure you check to make sure you got the negatives right. And we get 4x squared minus 3 and x minus 4, because that works. So make a list of 15 perfect squares. I'm not going to do all 15, but it's like 1 times 1, 2 times 2, 3 times 3, so on and so forth. Perfect cubes are numbers that multiply itself. So 10 perfect cubes, that'd be 1 times 1 times 1, which is 1. 2 times 2 times 2, which is 8. 3 times 3 times 3, which is 27, and so on. Okay, knowing those kind of makes this next part a lot easier, where we simplify radicals. Okay, so the square root of 63, although it seems like it would be a perfect square, it's not. I'm going to look for a perfect square, 9 and 7. 9 is a perfect square, that's 3 and 3. So we get to take out the two equal factors, which is the 3, and I'm left over with the 7 behind, stays in radical jail. Here I'm looking for 3 equal factors. Now, I know this is 9 times 3, and this is 3 and 3, so I do have 3 equal factors, so I get to pull out a 3. Nothing's left behind. This guy, sometimes it's best to just write it out as separate pieces. This is going to be 9 times 2, which is 3 and 3, so I'm going to be able to pull out a 3. I'm going to leave 2 behind. This one, I'm looking for equal groups. Remember, x to the 8th is really just 8 x's, so can I get 2 equal groups of x's? And I could. X to the 4 and x to the 4, and that gets to come out. And then last but not least, I can't get equal groups of this, but I could get y squared, and then just have a y left over. So there's my y squared gets to come out, and a y is left over in the radical. And there we go. So sometimes easier to look at it as separate pieces, The exponents are kind of easier. Just trying to divide it by 2 and get 2 equal groups. If there's leftovers, it's going to stay in the radical. Fractional exponents means I'm going to go ahead and just get a different look on this. This number here goes into my index right there, and this number here is going to do an overall power to my radical that I get. Here I'm going to get plus square root, that's 36 to the first power right there. Again, when there's 1 on top, you don't really have to do that because it doesn't do much. Now, if we know my perfect squares, 64 is a perfect cube. 4 times 4 times 4 is 64, so I know that this is just going to become 4 to the first power plus, and 36 squared is 6 times 6. So it's going to be 6 to the first power, so that gives me a total value of 10. Rationalizing, we just multiply top and bottom by rad 7. We can't have a radical in the denominator. Now rad 7 over rad 7 is just 1, so we're going to get 6 rad 7 over, and then rad 7 times rad 7 is just the number 7, right? Any radical times itself just becomes the number without the radical. All right. Tell whether the graph of the function opens up or downward. Well, we want to look at the a value. If the a value is greater than 1, it's going to be, or sorry, greater than 0. Let's write that. That's much better. So if a is greater than 0, it's going to be opening upward. And if a is less than 0 or negative, it's going to go down. And so this is negative, so this is going downwards. Identify the vertex and solutions of the parabola. So the vertex is at, looks like 4 and negative 4. The solutions are my x-intercepts, so that looks like it's at 2, 0, and that's going to be 6, 0. And is it a maximum or minimum? Well, this is not going to have a maximum. It goes on forever, so this is going to have a minimum, and it's it's at negative 4, but it just asks for the minimum. Identify the domain and range of the quadratic. So in the quadratic that we've been looking at, the domain is always negative infinity to positive infinity. Now the range, however, is the y values. So this is going to go all the way up to, it looks like 5, and then go down to infinity. But we usually start with infinity, so we're going to start with infinity and go all the way up to 5, and we're going to bracket it because we're going to include 5 in that value. All right, find the axis symmetry of the quadratic function given by the equation y equals 3x squared plus 6x plus 4. So we have this little equation which gives us the x value, which is negative b over 2a, and the x value of our vertex is the same as our axis of symmetry. So we can just plug this in. So 6, or a is 3, b is 6, and c is 4. Not that we need this c, but that is there. So we get negative 6 over 2 times 3, which is going to be negative 6 over 6, which is negative 1. So our axis of symmetry is x equals negative 1. Good thing to have on your note card right there, the axis of symmetry. All right, 2 more pages. Find the vertex. So to find the vertex, we use that same formula. X equals negative b over 2a. My a is negative 2, my b is negative 12, so I'm going to get negative 12 over 2 times negative 2. That becomes positive. This is 12 over negative 4, which is going to give me a negative 3. So the x value is negative 3, and then I just got to plug it back into this equation and evaluate to get the second part. So we're going to get negative 2 parentheses minus 12 parentheses negative 16. We're going to plug that negative 3 right in there and evaluate. And we can evaluate that pretty easily. We go negative 2 parentheses negative 3 squared. Again, use those parentheses. Minus 12 parentheses negative 3 parentheses and minus 16. And I get 2. So that ends up being 2 right there. So negative 3, when I plug in negative 3 into the function, I get 2. And there it is. Solve by factoring. So we're just going to factor this normal, and then negative 8 and 2. I believe that would be positive 4 and negative 2. So we get x minus 2 equals 0 and x plus 4 equals 0. So we're going to set each one of those equal to 0. Now I'm going to add 2 over, so I get x equals 2. And subtract 4, get x equals negative 4. Alright, next one, we get negative 40 and negative 3. So what multiplies to 40 but adds to 3? My first thought is 4 and 10, which will not work. Now I'm thinking maybe 5 and 8 would probably be the best one, so that's going to be negative 8, positive 5. So we're going to get x minus 8 equals 0 and x plus 5 equals 0. Now if you notice here we got 4 and negative 2, my answers was 2 and negative 4. So when it's the shortcut easy one, it's just the opposite what you see. So negative 8 and 5, so my answers are 8 and negative 5. Okay, so again, find the solution by completing the square. So this time we're going to move the 3 over. So I get x squared plus 2x plus blank equals negative 3. And now to complete this, we need to do b divided by 2 squared. Okay, so that's going to be 2 divided by 2 squared, or 1. So this is going to become 1. Whatever I do to one side, I have to add to the other side. And so here, we're going to end up with this is going to become what multiplies to 1 adds to 2. That's going to be x plus 1 squared equals negative 2. Now this is negative 2, so it actually has no solution. So we just write no solution, but we tried, because I would square root this, and you can't square root a negative 2. All right, complete the square. This time we should get an answer, because it's a positive number over here, and we're going to do b divided by 2 squared. So 6 divided by 2 is 3, 3 squared is 9. Add 9 over there. This is going to turn into x plus 3. 3 times 3 is 9, 3 plus 3 is 6, and 25, so square root that. We get x plus 3 equals plus or minus 5. So I'm going to get minus 3, so I'm going to get negative 3 plus 5 and negative 3 minus 5 as my two answers. And this would end up being positive 2, and my other answer is negative 8. Use the quadratic formula. So again, we're going to have to know the quadratic formula for this one. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. That should be on your note card, unless you want to memorize it, which you can. A equals 3, B equals negative 6, and C equals 1. And we'll plug it in. So we get negative 6 plus or minus the square root of negative 6 squared minus 4, 3, 1, all over 2 times 3. So I like to evaluate the inside first. This is going to obviously be just 6 plus or minus and 6 on the bottom. And this is going to be negative 6 squared, that's going to be 36 minus 4 times 3 times 1, which is 24. Okay, so if you left it like that, you technically have the right answer, but the square root of 24 would break down. You could do 4 times 6, and that would eventually, we could break that down to 2 rad 6 over 6. And I can divide everything by 2, boom, 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 and that would be 3, 1, and 3. So I should get 3 plus or minus the square root of 6 all over 3 as my final answer. Quadratic formula yet again, and any method, and then which one represents a quadratic function. So we'll go ahead and bust these 3 out. Alright, so A is 3, B is 1, and C is negative 1. So I'm going to plug in the formula negative 1 plus or minus the square root of 1 squared minus 4 times A times C all over 2 times A. So the inside is going to be 1 squared, which is 1, minus 4 times 3 times negative 1. Which is going to give me 13, which won't reduce, so I get negative 1 plus or minus the square root of 13 all over 6, can't go anywhere from there, There it is, which again, that is technically 2 solutions. Any method, I'm going to go ahead and, first of all, factor 2 out by dividing both sides by dividing everything by 2. So that should just leave me with x squared minus 3x minus 10. And then I'm going to say, can I factor this? Are there any numbers that multiply to 10 and add to negative 3? I'm thinking negative 5 and 2. Let's take a look. Negative 5, positive 2. Yep. And if it's a simple one like this, we just go with the opposite answers. And there we go. And this one, again, I'm going to try, I think negative 2 and negative 3 would work. So 6 and negative 5, so negative 2, negative 3, which would make my answers 3 and 2. So factoring, by far, fastest method. All right, this is exponential. I know that because the x is an exponent. This is linear. It's just a line. Linear. And then this is a quadratic that we are most familiar with this last lesson. And so there is the quadratic table. All right, that is all.